So we just finished talking about the arithmetic type of sequences, and now we are going to move on to the other type of sequences, which deal with multiplying patterns. This part will be the last page of the note packet on recursive sequences. This is the page you need to be on in your notes. Pause the video if you need to find it. So this type of sequence, where we are multiplying, is called geometric. I apologize that this was a little blurry, but you have it on your paper. Fill in the blanks. Geometric sequences are ones related to exponential functions, where we can find any term by thinking about how many times we have multiplied the common ratio. In other words, the R value that we talked about the other day. Pause if you need to copy this. On the next question, we want you to change the 3 to be 2 because we had only 2 lines. So find the next 2 terms in the geometric sequence and then write the recursive definition. Pause the video right now and go through and find the next 2 terms in each of the following. In part A, it was a times 3 pattern, so the next 2 terms are 54 and 162. In part B, it was a times -5 pattern, so the next 2 terms are -500 and 2500. In part C, it was a divide by 4. However, we don't do division, we do multiplying. The opposite of dividing by 4 is multiplying by 1 over 4, giving us the next 2 terms as 2 and 1. Part E, the next 2 terms would be -96 and 192 with a times -2 pattern. And part F, you may have noticed, divide by 10, which again would be a multiply by 1 over 10. So the next 2 terms would be 0.4 and 0.04. Make sure you have all those answers. So now I want you to try the next part, which is to write down the recursive definition for each of these geometric sequences. If you look back in your notes, our general definition is that we write a sub 1 equals whatever it is, and a sub n equals a sub n minus 1 times r, where r is that common ratio that we just found. So pause the video again and see if you can write down each of the definitions. Part A, the a sub 1 is 2, and a sub n equals a sub n minus 1 times 3. In part B, a sub 1 equals 4, and a sub n equals a sub n minus 1 times -5 should be your function. In part C, we have a sub 1 equals 16, and a sub n equals a sub n minus 1 times 1/2. Part E is a sub 1 equals -6, a sub n equals a sub n minus 1 times -2. Lastly, part F is a sub 1 equals 4000, and a sub n equals a sub n minus 1 times 1/10. If you need to go back and look at any of these again, make sure you do and that you have your notes correct. The next question says determine whether each sequence is arithmetic, geometric, or neither, and explain. I'm going to have you pause the video and try this on your own. If it's arithmetic, remember it's an addition or subtraction pattern by the same amount each time. If it's geometric, it's a multiplying by the same amount. Pause and go for it. In the first set of numbers, we have a +5, then a +3, then a +6. Therefore, it is neither. I forgot to write that in. The first one is neither. The second one is a +5 every time, therefore it is arithmetic because it is addition pattern. The next one is a times 3 each time, so it's geometric because it is a multiplying pattern. The last one adds 6 for the first 2 and then adds 8, so therefore that is also neither. Make sure you have each of these answers correct in your notes. The last question says the diagram below represents the first 3 terms of a sequence. Assuming the pattern continues in this manner, identify the sequence as arithmetic or geometric and write the recursive definition for it. So the first thing we need to do is to identify what each term is. So go ahead and count in the colored squares here. Count how many colored squares you have in each and write them down. Those give us our first 3 terms of this sequence. You should have counted 12, 16, and then 20. Now the next thing we need to know is the pattern going up by an addition? Is it multiplication? And what is that? Is it a common difference or is it a common ratio? Go ahead and decide what the pattern is. Hopefully you were able to figure this out, that it was a +4 pattern pretty quickly. Okay, so now try to write your recursive definition. Oh, and remember it asked, is it arithmetic or geometric? So write that down too. Pause the video before you look at the answer and try it on your own. The correct answer is that it is an arithmetic sequence with a sub 1 equal to 12 and a sub n equal to a sub n minus 1 plus 4. Pause if you need to. This is the end of your notes on recursive sequences. Go back and make sure you have all the notes that you need that are correct. If you need to rewatch any of the videos, please do so at this time before moving on to the exit ticket for today.